Hello, ladies and gentlemen. We've got our Unit 2 test coming up. We need to go through sort of converting angles from degrees to radians. We've got some arc length, we've got some sector area, we got some right triangle trig, and some solving. So I've got all those in here. This whole packet is stuff that you're going to see on your test. So let's see if we can start off just converting some angles. If I give you degrees, you want to cancel out degrees. So the way I remember this is I'll put 180 degrees in the bottom, and there are pi radians in 180 degrees. So now radians win. And you can use your calculator to help you here. If you just reduce the fraction, 135 over 180, math frac, 3/4. So this is 3 pi over 4. Now, that's one you should be able to do without a calculator because that's a terminal point we know. 50 degrees, though, is not. So you do 180, pi over 180. 50 over 180 is 5 over 18. It is negative, so negative 5 pi over 18. That's in radians. If you want to go the other way, you want to cancel out the radians, so we'll multiply by 180 over pi. The pi cancels out, and 180 divided by 12 is 15, so this is negative 15 degrees. Same game, multiply by 180 over pi. Radians cancel out, and if you do 14 times 180, and then you divide by 15, you get 168 degrees. So this is 168 degrees. That's just converting. That's not something you're going to do a lot of, but you need that skill on occasion, especially degrees to radians, for problems like this. So you have these formulas, arc length, area of a sector, angular speed, linear speed. You need those for problems like this. If I'm asked to find the arc length and area of a sector, I need these formulas, arc length, area of a sector. However, theta has to be in radians. Right now, theta is in degrees. So you need to take 25 degrees and multiply by pi over 180, which then that will reduce to 5 pi over 36. If you do not convert this into radians first, all your formulas that we know don't work. So now I've got that, I can find the arc length, that's S equals r theta. So S equals the radius is 18, and theta is 5 pi over 36. And when you type that in, 18 times 5 pi over 36, you get about 7.85. 7.85. It says nearest hundredth, so nearest hundredth, 7.85 what? Meters? Okay, 7.85 meters. If you're asked to find area of a sector, that's 1/2 theta r squared. So 1/2, 5 pi over 36, and the radius is 18. So this is very much just calculator work. 0.5 times 5 pi over 36 times 18 squared. 70.69 in hundredths. 70.69 meters. Oh, it's area, so meters squared. 70.69 meters squared. That's arc length, that's sector area. Okay, great. Let's try some word problems now. So this says you're standing 100 meters from the Sears Tower. I think it's a Willis Tower now, but fine. There we go. And so here's my, that bothers me. Try again. There we go. So here's my triangle. I am 100 meters from this skyscraper. Here's the tower. Yeah, this is buildings, people working in there, whatever. Okay. We don't know the height of the tower. That's h. But we do know that if I'm standing here and I'm looking up with an angle of elevation of 77 degrees. So remember, that's always from the horizontal. You need to draw a horizontal and then you look up. You look up at 77 degrees. Now we got to figure out what trig function makes the most sense. In relation to 77 degrees, we have opposite and adjacent. So I'm going to say the tangent of 77 degrees is h over 100. And to solve that, you need to multiply both sides by 100. So make sure you're in degrees. Right now I'm in radians. Now I go, quit. 100 times the tangent of 77, and I get 433.15. So h is 433.15, and that is meters. So about 400 meters, which is like, I don't know, 1,300 feet, something like that. Maybe a little more. Sounds reasonable. Suppose one of your friends at the top of the Sears Tower, what is the straight line distance? So I think what they're saying is you got somebody else sitting up here and they're looking down at you, and I want to know what happened. What's this distance? So you can do this a couple ways. You could do Pythagorean theorem, or you could do maybe like say the cosine of 77 is adjacent over hypotenuse, and then you could do 100 divided by the cosine of 77. So 444.54. And that is also meters. Again, you could do Pythagorean theorem if you know h. The only thing about that is you want to make sure you don't round anything. So if you do Pythagorean theorem, come up here and take this actual decimal, square that, plus 100 squared, and then if you square root it, you should get the hypotenuse anyway. So same thing. As long as you keep all the decimals, it doesn't matter how you do it. You can use the right triangle trig, or you can do Pythagorean theorem. Standing at Eiffel Tower. Okay, so Eiffel Tower, 300 feet in the air, that's 300 feet. And you look down at your friend, notice angle of depression. So angle of depression is from the horizontal. So if you are at the top of the Eiffel Tower, I'm going to draw this picture now, and we'll clean it up a little bit. But all of this stuff I don't need this. Okay. Angle of depression has to be from the horizontal. If you put 78 degrees right here, you miss the problem. Okay, because you are staring out. This is the Eiffel Tower right here. Okay, Eiffel Tower, hooray. Okay, we're right there at the top. We are looking down at an angle of depression. It changes from 65, so 65 degrees, to 78. So you look at them, they're out there, then you look at them again, and they're a little bit closer because the angle is now bigger. This is 78 degrees. This whole angle is 78 degrees. If you label the picture wrong, then your right triangle trig is going to come out wrong. So it's really important you can get this picture. Now we have alternate interior angles. You see alternate interior angles? These are parallel lines and a transversal. You have parallel lines right here, and you have a transversal. So if this is 65, then this is 65. And if this angle is 78, then this angle is 78. Once you get the picture, this problem isn't bad. I'm going to label this guy, let's just call that X, and then I'll call that D. That's the distance I actually want to know, how far this person walked from here to there. So the first thing I'll do is I'll figure out maybe just how far they are away from the Eiffel Tower right now. So I'm just looking at this triangle. I would say the tangent of 78 is 300 over X, and I can find that by doing 300 divided by tangent of 78, which is 63.77. So X is 63.77, and that's feet. So first thing I'm going to do is figure out how far they are from the Eiffel Tower at the end. Now I'm going to figure out how far they were at the beginning, so I'm looking at this triangle. Okay, I'm still using tangent. I still have opposite and adjacent, but now it's the tangent of 65 is 300 over. The adjacent side is that whole thing, so that would be X plus the distance. So when I solve this, I'll do 300 divided by tangent 65, and I get 139.89. 139.89, that is X plus D. That's the sum of those two distances. To find just the distance, you need to subtract. So you take 139, and you subtract your 63, and that tells you, wait, what? Quit. Okay, let's try that again. Get out of here. This guy minus the 63, and I get 76.13. So the distance is 76.13 feet. That means they walked 76 feet, and then they were 63 feet away from the Eiffel Tower. At one point, they were about 140 feet away. They walked 76, and they were still 64 away. You just have to make sure you draw the triangle correctly. If you get everything labeled, that's a pretty easy problem. All right, let's keep moving along here. We got angular speed problem. So the formula is r theta over time for linear speed. Angular speed is just theta over time. So it does actually ask you for angular speed too. That's linear speed. Angular speed, we use omega, is theta over time. That's a lowercase omega. Okay, so diameter of the wheel is 87. Theta is radians. Now, every time you go around in a circle, that's 2 pi radians. So if you do 300 circles and each one is 2 pi radians, then theta is 300 times 2 pi, which is 600 pi radians. Over, this is 1 minute. 1 minute. So this is radians per minute. This is 600 pi radians a minute. It doesn't actually give me units, so I'm just going to leave it as radians a minute. That's the angular speed. RPMs is an angular speed. It's just not in radians. So I usually want my answer in radians per minute. Now to find the linear speed, I take that number and I multiply by the radius. The diameter is 80. That means that the radius is 40. So 40 times 600 pi over 1 minute, and that is 40 centimeters. So again, it doesn't actually give me any units, so I could probably leave it in centimeters a minute, but I do want to know it as a number. So 40 times 600 pi is 75,398.22. 75398.22 centimeters a minute. It doesn't give me any units, but just because I feel like we're going to probably have some dimensional analysis, I'm going to convert it to meters a second just for practice. So if I want to convert this to meters a second, I need to know how many centimeters are in a meter. 1 meter is 100 centimeters, just like there are 100 cents in a dollar. Cent means 100. So now I have meters a minute, and then I know that there are, in 1 minute, 60 seconds. So then minutes will cancel out, and I'll have meters a second. So typing that in, I need to divide by basically 60 times 100. So divide by 60 times 100. And you get 12.57. So 12.57 meters per second. Okay. So you could be asked to leave it alone. Like if it gives you a unit, you need to make sure you match that unit. This is 12.57 meters per second. That's that many centimeters a minute. Okay, fine. Now we're going to solve. So for solving, you have to pay attention to the directions. This says in the interval 0 to 2 pi, which means you should have no negatives, and you don't need to do the plus 2 pi n kind of thing. The first thing in this problem is you see that you have a sine and a cosine in the problem. That means you're probably going to have to factor. So I'm going to factor out a sine, and now I have the cosine of x minus 1 equals 0. If I were to distribute, I would end up back there, but this is called the zero product property. And now either of these factors can equal 0. Either sine of x has to be 0 or cosine x minus 1 has to be, has to be 0. So that means cosine of x has to be 1. So you need to think on the unit circle, when does that happen? When is sine 0? That's y. Sine is the y. So sine is 0 right here at 1, 0. And sine is also 0 back here at negative 1, 0. And where's cosine 1? Well, cosine is 1 right here. So it kind of is a double count. That means that our answers are at 0 and our answers are at pi. Those are the two solutions to the problem. And since it says between 0 and 2 pi, you do not need to do anything else. If you put plus pi in, you are adding solutions to the problem. So don't. You are finished. It's 0 and pi. Those are the only two spots that work. Now the second one, there's also a giveaway that you need to factor, and that is you have a sine squared and you have a sine to the first. So you need to do, like to do a u substitution just to help make this feel like an easier problem. When you factor that, let's see, 2 is prime, so I don't have a lot of choice. I want negative 4 and negative 1 because that'll make negative 5 in the middle. So 2u squared minus 4 minus 1, that makes negative 5 plus 2. Good. So now I can say, well, then u has to be 1/2 or u has to be 2. But we're not trying to solve for u, we're trying to solve for x. So let's go back and say, well, u is actually the sine of x. So where's the sine of x 1/2 and where's the sine of x 2? Well, sine of x is never 2 because sine has to be on the unit circle. It's got to be between negative 1 and 1. So that doesn't happen. But sine is 1/2 in two places. First of all, sine is positive in the first and second quadrant. And if you're talking about sine being 1/2, this is 1/2, and across from that is 30 degrees. So it's my 30-degree reference angles in the first and second quadrant. That would be at pi over 6 and 5 pi over 6. And again, you cannot do anything else with that. Those are the only two answers that make any sense. Okay? Pi over 6 and 5 pi over 6. Let's try a couple more. These are all solutions now, so that means I'll have to deal with the plus 2 pi n. But let's first get cosecant squared by itself. And now I am not very good with my cosecants. I don't know every cosecant on the unit circle, but I do know all the signs. So what I'm going to do is take the reciprocal of both sides. Since this is a proportion, you can do that. Sine squared is 3/4. Sine squared of x is 3/4. Now you square root both sides, and this is a big source of confusion. When you square root both sides, you need to put plus or minus. The square root of 3 is the square root of 3, and the square root of 4 is 2. So now I need to figure out where sine is either plus or minus radical 3/2. That's the 60-degree reference angles. So those are 60-degree reference angles, and those are 60-degree reference angles because you have the positives are up here, and the negatives down here. So to answer the question, you say x equals pi over 3. Pi over 3 plus, I can also say pi n, that picks up these two, or 2 pi over 3 plus pi n. So that's all the solutions. Because this goes straight through the origin, you can say that they are pi radians apart and pick up both of them. Let's try another one. This has a bunch of different degrees for tangent, so that means I'm going to do a u substitution. 3u cubed minus 3u, it's a squared, minus u plus 1 equals 0. I need to factor, and it's got 4 terms, so I'm factoring by grouping. 3u squared is the GCF of the first half, and I'd have u minus 1 minus. These don't have anything in common, so I'll just put a minus 1, and then it's u minus 1. So my factors are 3u squared minus 1 and u minus 1. So either u squared is 1/3 or u is 1. Those are my two options. Where is u squared 1/3? Well, okay, let's go back. That's tangent squared of x, or tangent of x equals 1. So I still got to work on this. I have tangent squared, so when I square root both sides, I get tangent of x equals, when you rationalize that, you're going to get radical 3/3, and don't forget plus or minus. So 1 over radical 3 rationalizes radical 3/3. So where is tangent radical 3/3? Well, that's all the 30-degree reference angles, so all those work. All the 30 degrees work. And where is tangent 1? Tangent is positive 1 when opposite and adjacent are the same, so that's a 45-degree reference angle, and tangent is positive in the first and third quadrant. So we have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are the 30s. You have pi over 4, and this is 5 pi over 4. So how can we write that? I'd say, let's see, how about pi over 6 plus pi n? That gets those two. How about 5 pi over 6 plus pi n? That gets these two. And then the last two would be pi over 4 plus pi n. That gets these two. So now I have all 4. Oh, well, I guess it's 3 sets of 2, so all 6. A little tricky, kind of a long problem. You have factoring and u substitution, all that, but at the end, when you get to here, it shouldn't really matter. It should be easy for me right now because it's just a matter of, do you know the unit? A couple more problems. Now, this one has been changed. I believe originally it had a 3x in there. Go ahead and make that an x. We haven't done double or triple angles yet. Now I'm just going to isolate tangent. So tangent of x is -1 over radical 3. I feel like this is the same thing we just did. That's negative radical 3/3. When you rationalize it, you get radical 3/3. So again, tangent is radical 3/3 when you have a 30-degree reference angle, but tangent is negative in the second and fourth quadrants. So that's a 30-degree reference angle. That means this would be 5 pi over 6 plus pi n. That gets you all the answers. Now, tangent is not positive here, so you don't need to do the other set. It's only negative. We didn't square root both sides. Last one, when you see a cosine and a cosine squared, you're going to have to factor. So let's factor out a cosine of x, and you're left with, let's see what's on the inside, 1 minus 2 cosine x. And I need to know when each of these factors equals 0. So when does cosine of x equal 0? And when does, can I do this in my head? It'd be 1/2 equals cosine of x. If you solve that equation, you get 1/2 for cosine. If it helps you, you can do it with u substitution as well. Some people like to do it like this, 2u squared and factor out a u, like that. Wait, that's wrong. What's going on here? It's 1 minus 2u. If you factor out a u, you get 1 minus 2u. That looks better. Okay. Regardless, you're going to end up here. Cosine has to be 0 or cosine has to be 1/2. So where is cosine 0? That's the x value. So x is 0 on the y-axis. So this is 0, 1. That works. And down here, 0, -1. Cosine is 0 at those 2 points. Where's cosine 1/2? So cosine is the x. That's the long side. I want x to be the short side. So if I draw my triangle, it's like that. The 30 degrees up here, that means a 60-degree reference angle. And cosine is positive in the first and fourth quadrants. So the 60-degree reference angle is there. I can say pi over 2 plus pi n. That gets those two. Then I have to say pi over 3. But these aren't pi apart. So you have to say this, and you just have to add 2 pi every time. Same thing down here. This is 5 pi over 3 plus 2 pi n. So that is all of your answers for this factor problem. Now, the last section that we have here is, can you use inverse trig? And there's a trick to this. There's only one right answer. So if it says inverse cosine, you have to remember that inverse cosine has a restricted range. You have to be up here. Now, we need cosine to be negative, so we are in the second quadrant. And if we want the x to be the long side, it's going to look like that. This is a 30-degree reference angle. So it's probably, if it was in degrees, it'd be 150 degrees, but we probably want our answer in radians, so that's 5 pi over 6. Either one is right, it's just make sure you probably default to radians, so 5 pi over 6. Now the next one's a little tricky. You have to realize that by saying the inverse tangent of radical 3 is theta, some angle, that means that the tangent of theta is radical 3. And tangent has to come from the right side if you're talking inverse tangent. So if tangent is radical 3, we're in the first quadrant with a 60-degree reference angle. And I just remember that the tangent of 60 is radical 3. So if it's a 60-degree reference angle, I can start to label this thing and say, well, that's radical 3 over 2, and this is 1/2, and we're on the unit circle. So what's the cosine of that angle? The cosine would be this right here. So this is 1/2. This equals 1/2. You can figure out what the triangle is, and then you just got to pick the right trig ratio. Last one, we're going to play the same game. This is telling you right here that there is an angle whose cosine is 3 over 8. So I'm going to draw a triangle and say, okay, your adjacent over hypotenuse is 3 over 8. This is the angle I'm talking about. I don't know what this height is, but I can use Pythagorean theorem. 64 minus 9, and that's going to be radical 55. So just using Pythagorean theorem, you can figure out the missing side. I need that because I'm asked to find the sine of the angle. The sine is opposite over hypotenuse, so this is radical 55 over 8. And the cool thing is, you can check these on your calculator. If you do the sine of the inverse sine of 3/8, you should get radical 55 over 8. See, we did it right. But I don't want a decimal, I need an exact answer. So you have tons of examples of all these problems if you go through your notes, if you check out your warm-ups. If you can do those, and you can do your study guide, and you can do your My Math Labs, you are ready to go. So good luck on the test, and I'll see you when we're done.